Hello! Today we're going to be doing LeetCode problem 1287. Element appearing more than 25% in sorted array. Okay, this problem states given an integer array sorted in non-decreasing order. I swear, these problems. So basically ascending order. Keep it simple, stupid. Ascending order, non-decreasing. Who are they trying to fool? There is exactly one integer in the array that occurs more than 25% of the time. Return that integer. So in the first example, here we go. Output is 6 because 6 occurs more than 25% of the time. Pretty straightforward. Okay. All right. So for this problem, there's a lot of assumptions that can be made to make this quite simple. So basically there's one element that occurs more than 25% of the time. So we just need to find that element, and then when we do, we're done. So the first thing we're going to do is define an integer, and we'll call it size, equals our length. So our programmers are so lazy, like can't type the whole word? Come on. All right, then we need to define, okay, so there's one element that occurs more than 25% of the time, so we need to find that element, and we're just going to take size divided by 4, and that will give us that element. And then the count, and we'll start that at 1. And then we need to have a starting point, so we'll call this the pointer. And that's going to equal our, we're too lazy to type out the word array, R0. All right. So now we just need to iterate through these. No IntelliSense in the LeetCode. So for int I equals 1, and the reason we start at 1 is because we're going to compare every element in the array. So when we first iterate through this, we're going to use array 0. We can't compare array 0 to array 0, so we need to start with 1. So I is less than R, less than Scott. I is less than R length. I plus plus. All right. So if pointer equals array sub I, so if we're gonna not one, yeah, that was right. Okay. All right. So if basically we're looking, because they're in sorted order, we're gonna okay. So they're in sorted order. So if the pointer equals, if the pointer, which is array sub 0, equals array sub I, which is 1, so if the pointer equals, if the first element equals the second element, then we're just going to increment the count. And we'll keep doing that because they're sorted until that's not the case. Else, we're going to set the count back to 1. Helps if I spell else right. Holy hell, that wasn't even close. Scott. All right. Maybe this would help if I put this in. I'm a C# developer, so I put the curly brackets on the next line. So, it's Friday night, so I'm had a few cocktails, but here we go. Okay, so there. All right, so plain and simple. Iterate the count while the numbers are the same. Otherwise, set the count back to 1. Okay, if at any point the count is greater then quarter, there's only one element that's going to be greater than 25%. So we're going to return, we're just going to return that number. Otherwise, pointer equals, good God, R sub I. All right, and then we're going to return the pointer. So at some point, we're going to find an element that's greater than 25%. And then we're just going to return that. Okay, let's run this, see where I messed up. Are you kidding me? That was accepted. I should drink more. Submit. Well, it's submitted, so we're good to go. Alright, so the time complexity of this is O of n. It just depends on the size of the input array. And the space complexity is O of 1. We're literally iterating through the array, so there's nothing to nothing we need to do to increase the space. So hope you enjoyed this. Thanks for watching, and we'll see you next time.